Welcome to solverfy.
So we know that power can be calculated by two forms. P equal to three forms. IV, right? The current times the voltage. Due to the Ohm's law, we can also write to this as P equal to V squared over R, or P equal to I squared times R. Okay, that's all we need for this question. So for question A, we know that the power is 5 volts. So we can use this equation. So V equal to P R, take a square root, right? So we're plugging the number 5 times 15,000, which is going to be, and take a square root, which is going to be about 274 volts. For question 2, again, we use this equation. The power ratio of power rating is going to be V squared over R, which is 120 squared over 9,000, and it's going to be 1.6 volts. So for question C, since they are in series, they have the same current go through them, right? So in this case, we're going to use this one. Okay. So they have the same current. So if you have a larger resistance, you have more power, right? So the power on the 150 resistor is always going to be larger than the power on the 100 ohm resistor. So all we need to care about is whether this 150 ohm resistor gonna reach 2 volts or not. So when this 150 ohm resistor reach the 2 ohms, 2 volt, so P equal to IR squared, right? So the current gonna be equal to square root P over R. P is 2, R is 150, so the current is gonna be 0.115 ohm ampere, right? Okay. So in this case, the P115 gonna have 2 volts, and P100 gonna have I squared, I times R squared, which is 0.115 times 100 squared. It's gonna be this should be I squared over I squared times R, which is going to be this squared times 100, and say it's going to be 1.32 volts. And that's the heat generated by each resistor.